warm good morning, dear students. Welcome to this digital chemistry class. As we are doing this unit, that is unit 7. Name of the unit is Equilibrium. So in this particular chapter, one video already I have shared yesterday. So today I'm going to take the topic in the next. So dear students, in equilibrium, basically we studied that it is the state in which there are no observable change as time goes by. It means that equilibrium is that stage, it is the balanced stage where the rate of forward and the reverse reaction are always equal. Number one is rate, number two is concentration, in which the concentration of the reactant and product remain constant. So when concentration of reactant and product remain constant, when rate of forward is always equal to the reversible, that is called equilibrium stage. So in equilibrium, there are two types of equilibrium. First is physical equilibrium, second is chemical equilibrium. In physical equilibrium, we are going to take physical state. Okay, suppose H2O is in liquid and gas. When it is in equilibrium, in both the state, that is called physical equilibrium. Whereas in chemical equilibrium, basically it is homogeneous and heterogeneous. So it is talking about we will talk about the chemical. Okay, so next is, there are two types of equilibrium, physical and chemical equilibrium. Already. Now physical equilibrium, we will talk about the physical state, as we have said here, gas. Here you can say this is gaseous state, and inside this there is liquid state. When we are talking about that state, that is called physical state. And in chemical state, we are talking about the chemical reaction that is occurring inside the chemical.
General characteristics of equilibria involving physical processes. At equilibrium, the measurable properties of the system becomes constant. At equilibrium, there is a dynamic balance between the two opposite processes. The equilibrium can only be attained in a closed system. When equilibrium is attained, there exists an expression involving the concentration of substances involved in equilibrium, which reaches a constant value at a given temperature. The magnitude of the constant value of the concentration indicates the extent to which the process proceeds before reaching equilibrium. Equilibrium in chemical processes. Dynamic equilibrium. The reactions in which products do not react to form reactants back are called irreversible reactions. For example, silver nitrate reacts with sodium chloride, gives rise to silver chloride and sodium nitrate. The reactions in which products react to form the reactants back are called reversible reactions. The reversible reactions are represented by putting two arrows pointing in opposite direction. For example, hydrogen reacts with iodine, gives rise to hydrogen iodide, the state at which there is no further change in concentration of reactants and product is called chemical equilibrium. At equilibrium, the rate of forward reaction is equal to rate of backward reaction. Chemical equilibrium is also dynamic in nature because reaction does not stop at equilibrium. The rates of forward and backward reaction being equal, the concentration of reactants and products remains constant. Let us illustrate the state of equilibrium with the help of example. Calcium carbonate, when heated to 1073 Kelvin in a closed evacuated vessel, starts decomposing to yield calcium oxide and carbon dioxide gas. Carbon dioxide builds a pressure. The pressure goes on increasing as the reaction proceeds and finally becomes constant and remains so as long as the temperature remains constant. It appears as if the reaction has come to a stop, although calcium carbonate is still present. This indicates that this system has attained the equilibrium state.
So in chemical reaction, if we will see the graph between concentration and time, so as the concentration increase and time increase, the rate of forward backward reaction is coming at one point where there is called equilibrium state. After this point, that the N2O4 and NO2 is always constant. Okay, so here also with the increase in concentration, you can see this is always constant, this is also constant. So the stage in equilibrium, after some time the stage will come the constant stage. So in chemical equilibrium, we are talking about the law of mass action or equilibrium equation, we can say. So in law of mass action, if we will talk law of mass action, in law of mass action, the rate at which a substance react is proportional to its active masses, and hence the rate of chemical reaction is proportional to the product of the active masses of the reactant. The law of mass action is also known as equilibrium equation. So law of mass action for a reversible reaction at equilibrium and constant temperature, it is a certain ratio of reactant and product concentration has a constant value. It means that we will introduce here K, which is the equilibrium constant. And what is the meaning of equilibrium constant? It is a number equal to the ratio of equilibrium concentration of product to the equilibrium concentration of reactant. It is simply ratio between equilibrium concentration of product and equilibrium concentration of reactant, which is each raised to the power of its stoichiometric coefficient. Okay, so this we have started yesterday. So now I am going to tell in detail about the law of mass action with the help of this example. Let's take an example. A react with B will give C and D, whereas small a is coefficient मतलब जब हम इसको बैलेंस करते हैं तो a कोई नंबर होता है, and the capital A, capital B, capital C, capital D are the reactant. A and B is reactant, whereas C and D is product. Okay, so in that case, if we will see, so the K will be written in this form. K will be written in this form, whereas you can see C and D is product. So it is the product of molar concentration of product and the product with the raised to the power of coefficient. Raised to power मतलब इसके ऊपर power में आप देखेंगे small c small d is written, divided by product of molar concentration of reactant with the raised to power the reactant coefficient. So if we will talk about N2O4 gases with 2NO2 gas, this is the reaction. N2O4 is reactant and 2NO2 is gas, so product. So NO2 and N2O system at 25 degrees Celsius, when the initial concentration is this, then N2O4 this, and then the concentration at equilibrium is this with the N2O this, whereas the ratio of the reactant concentration of equilibrium is this. So you can see the value that will come in the raised to the power. This is the raised to the power, this is the raised to the power, the value there is. So this is equilibrium constant, and equilibrium constant is defined by K, whereas the magnitude of K will tell us the equilibrium reaction. If the value of K is greater than 1, it will favor product, mean reaction will move toward product side. When K is smaller than 1, it will favor toward reactant, it means the reaction will be reverse. So this value of K is very important, which will decide the reaction will move toward forward or toward backward. So like this way. Next is equilibrium constant expression. Equilibrium constant can be expressed by using Kc or Kp. Kc in case of concentration, Kp in case of pressure. Kc used the concentration of reactant and product, Kp used the pressure of the gases reactant and product. So in case of homogeneous, the Kc, Kp. Now we should know the value of Kc and Kp. The equilibrium constant equation for the same reaction, if we will say in case of Kc, तो it will written very simple, Kc is equal to, तो इसको हम इस ब्रैकेट में शो करेंगे, NO2 square upon N2O4, that is written here. Whereas in Kp, you know the bracket has not written now. In place of bracket we are writing P, pressure. So this is the major difference between Kc and Kp. So again Kc and Kp, so you can see this is the bracket, and in case of P there is a pressure. So only this is the difference. So the major difference between Kc and Kp is told, that is this molar concentration is written in case of Kc and the P is written in case of pressure. Okay, so after this, next is in case of homogeneous mixture. Already I told you homogeneous equilibrium and heterogeneous equilibrium are two type of equilibrium in chemical equilibrium. In homogeneous equilibrium, it applies all the reactions in which all reacting species are in the same phase. Mean this gas and gas phase will be there. When there is reactant and product have same phase, then it is called homogeneous equilibrium. In that case, the Kc is not equal to Kp. In that case, particular Kc is not always equal to Kp. And the product Kc value will written in this way. Dear student, here I want to tell you, you should know the value of reaction, how reaction will write in form of Kc and how reaction will write in face of Kp. This is the most important. Only rest.
Law of chemical equilibrium and equilibrium constant. The law of mass action states that at constant temperature, the rate of a chemical reaction is directly proportional to the product of the molar concentration of reacting species, with each concentration term raised to the power equal to the numerical coefficient of that species in the chemical equation. Let us consider a simple reversible reaction. The reactants A and B react to form the products C and D. The concentration in an equilibrium mixture are related as, name it as equation 1. Equation 1 is called the equilibrium equation. Kc is called equilibrium constant, and the term is called the equilibrium constant expression. For a general reaction of the type, the expression for equilibrium constant can be written as, where C in subscript to K, that is, Kc is expressed in concentration of mole per liter. Law of chemical equilibrium can be stated as, at a given temperature, the ratio of product of equilibrium concentration of the products to that of the reactants, with each concentration term raised to the power equal to the respective stoichiometric coefficients in the balanced chemical equation, has a constant value. Let the equilibrium constant for the reaction be Kc dash. Then the relation between Kc and Kc dash is Kc dash is equal to 1 by Kc.
Simple. If I'll take some examples from the book, that is, write the expression of Kc and Kp if applicable of the following reversible. So you need to write the reaction in form of Kc and Kp. Suppose Kc, for first question, the product is H3O positive F negative upon HF bracket HF and H2O. In this way we will write. So this should be there in exam. Sometime this type of question is coming to write the expression of Kc and Kp for the following reactions. So answer is already given here. You can see this is Kc for this and this is Kc for N2O. So like this way you have to write. Second question is coming, that is the practical. This is first and this is second question, that is coming like this way. The following equilibrium process has been studied at 230 degrees Celsius. Okay, sorry, 230 degrees Celsius. When reaction is this. So in one experiment of concentration, the equilibrium are found to be value of NO is this much, value of O2 is this much, value of NO2 is this much. So what we will need to do, you need to write Kc value, calculate the equilibrium and put the value. So you can see here we have written Kc and we have substituted the value, and after that we calculated. After calculating we got that this is the value, that 6.44 into 10 raised to 5 is the answer. Okay, so this way the two type of numerical that is coming. Third type of question is there, the equilibrium constant Kp for decomposition of phosphorus pentachloride into phosphorus trichloride and molecular chlorine. This is in your textbook, it is given. So now you need to find out that 1.05 at 250 degree Celsius and 0.875 and 0.463 atmosphere. So you need to calculate the Kp. So again the same way, where we will writing Kc, here we will write Kp, we will put the value, we need to find out the answer will come 198. Okay, this is very simple. Just pause the video and then just calculate this. Once again I am going to share you the screenshot of these pictures. So you need to solve this question. Okay, so after this, equilibrium constant expression. This is also one important relation between Kc and Kp, how Kc is related to Kp. So this relation we need to find out. For that purpose we need to do one derivation that I'm going to tell you in the next video. So till then, take care, stay home, stay safe. Thank you, have a nice day.